Okay, we can start.
Excellent. Thank you very much. So welcome everyone. Another SMAC seminar here. We are continuing with the hands-on introduction to LaTeX. And a few weeks ago we had the first one in the series, and now we are continuing with more advanced features, how to automate the introduction of data into LaTeX documents. Speakers, as in the first one in the series, are Mohammad, Akhlaghi, and Sepideh, Eskandarlou. Sepideh will start, and then Mohammad will continue. We will continue with more after this one, with more advanced features. But we hope you can follow them as we come. Sepideh, please.
Hello, everyone. Thank you, Carlos, for your introduction. Please let me share my screen and start what we were doing in 2 weeks ago. Do you remember 2 weeks ago we learned how we can make our very basic document in LaTeX. It was our source, and by PDF LaTeX and name of our source, we could easily make our PDF. If I open my PDF, do you remember we learned how you put our title, author name, date, how we learn how divide our main text to the different sections, subsection and subsection, how insert image, table, and equation. The last thing we learned was how we can automatically put number for our equation, and don't worry about counting the equation and put the number for it. Now I want to go to my source and reference to this equation exactly at the first of the second section in here. For example, I want to come here and write for definition of magnitude C equation 1. Then I save it and run it again. You see in here, I refer to my first equation, but maybe our results are changed, and after 2 months, we decide to add another equation before this one. Please let me copy this one. Oh, excuse me. And okay. And come here and paste it and remove the first one and just put the very simple equation in here, and I want to save it again. You see in here the number of my equation is 1, and I refer to this one. But if I add another equation, the number of this equation changed from 1 to 2, but I forgot to looking for it in my main text and change it. This is something like a nightmare, because this is horrible. You look for the in which part of your text your reference to this equation and change it, and this is so difficult. But don't worry, because LaTeX has a command with a name of a label. You can use the label and define a name for your equation, for your equation with name of magnitude, and then exactly come here, and instead of writing the exact number, reference to the name of your equation, magnitude. before I run my source, please let me say that it is not necessary you put this equation before the name of your equation, but this is useful when your article become bigger and you are referring to many things inside your text. It is easy, you understand it is which magnitude, the equation, the table, or image. Now, please let me save it and again run it. In this part, you see automatically the number of equations change from 1 to the 2. If I come to my source and remove the first equation and save it and run it again, you see in here again automatically the number of the equation change to the 1. Now I want to show you you can reference to your you can use the label and reference to your section, to table, and everything you want. For example, I want to come after this section and use the label with name of section of a star life, and then go to the introduction, the first, and in here write C section and reference to this, the section of a star life, and put the dots and save it. But please let me, before running this, say that if you pay attention, when I add a label inside my source, I run my LaTeX 2 times. Please see what will be happen. In the first run, when I am running a LaTeX, instead of the number of section, put 2 question mark. Why? Do you remember that 2 weeks ago I said to you I want to discuss about this auxiliary file in the future? Please let me open this file and see what will be happen. In the first run, when you are using the label, the LaTeX save all of these label inside the auxiliary file. You see, this is my first reference, this is my second reference, and exactly write the number of the section and the number of page. If I run my source for the second time from this auxiliary file, the LaTeX read all the values and put them exactly in here. Now, please let me go inside our source and see how we can how we can refer to our image inside the text. You should come after the caption and in here write your label and a star life.
Awesome.
And
Sepideh figure.
oh, excuse me, yes, thank you. Okay, then I want to come exactly above the table, write figure star life in page of, but which page? For referring to your page, it is very easy. You should use the page ref command and exactly use the name of your image you define inside the label and put in here figure star life shows to us life cycle of stars. If I save it and run my source 2 times, in here, I could easily refer to the number of image and the number of page of image automatically. Now, one things are annoying me. It is difficult for me when I am reading this paper, scroll down, find this figure, look at this. I want to make it clickable. For doing this work, it is very, very easy. You should come to the inside the preamble region. And in this part, just use the clickable, yes, links package in here. The name of package is hyperref. But before running my source, please let me remove the auxiliary file, because in the auxiliary file, all the references are saved. I should remove it and then run it 2 times. You see, now all of my references are clickable. For example, if I click in a figure 1, I go to the figure 1, see it, and I can read this paper very easily. But another things, again, are annoying me. All of these red boxes around the references. I don't want this. I want to remove all of this. This is very, very easy. You should come before the hyperref and in the bracket, choose the color links command, and then choose your color link to color link to
link color.
Oh, okay. Color to blue. If I run it, you see now all of these references are changed to the blue, and I can easily go inside this page and read it. But the hyperref, but hyperref, you can do another good thing, and you can add the metadata to your paper. Why the metadata is useful? Because all of the search engine, for a search engine, the metadata is important, and they are looking for your information in your metadata. Please let me add the PDF title in my metadata and see what will be happen. My exciting project in LaTeX. If I save it and come in a command line and run it again, you see anything doesn't change in my paper. Where is metadata? I should come in here, and in my properties, you see I add the title of this work in my metadata. But if you attention, the title inside my metadata is completely different from the title in the paper. And if I send in this article for my colleague, she or he will be confused which one of these is correct. For avoiding this problem and for avoiding of the repetition, you can use the macros inside LaTeX, custom macros. For using the macros, you should write new command, and I want to use a variable with name of project title. you see, 2 times I am using the project title. Instead of it and instead of the repetition, I want to write my exciting project and then come and copy this variable and come and instead of writing the title, paste this one. Okay, please let me save and run it again and go to the properties. You see the title in my project and inside the metadata are similar. You can add extra things inside your metadata. For example, I want to come here and write the PDF author, put my name and my colleague, and then again I want to add the PDF subject to my first project in LaTeX. But if you see, I am using the author names again 2 times. I don't want to do this work. I just again use the macros, and now instead of project title, write the project author, and instead of this, write the author's name, my name and my colleague. Then again, copy this and write in this part. And this part again. And if I run my source, you see all of these metadata, such as a title, subject, and author name, are saved inside my PDF, and the title and author name exactly similar to the paper. Now, the main point things inside our paper is our result. How we can insert our result inside the paper. Please let me come above this equation and say, for example, in this article, following the selection criteria, we found, for example, 10 stars, while we found 10 stars, others, for example, found 7 stars. Now I save it and run my source. In above of equation, you see I report this result. Now, after 2 or 3 months, my results are changed, and I found, for example, 50 stars instead of 10 stars. If I save it and run it again, you see in this sentence, I find my result and change it from 10 to the 15. But in another sentence, I forgot, I couldn't find it and change it to the 15. When someone read your article, will be confused which one is correct, 10 or 15. For avoiding this problem, you can use the macros for reporting your result. You should exactly come here. And now for Anna, this is results. Use the macros again. New comment. Project selected. And I want to report I found 50 stars. 15 stars. And then come here, copy this variable. Instead of writing the 15 in the main text and 10, just put this variable in here. If I run it, you see in both cases I write 15. For example, if after 3 or 4 months you change your result and find 20 stars, you just should come inside the preamble and change this macros to the 20 and run your article, and everything will be changed correctly and you don't forget anything. But in the reality, our result is not just one number. It is more than one number. In some scenario, all of us are using the Python code, the shell script, and many things for analyzing our result. Please let me come in here and use this shell script for finding stars around this coordinate from Gaia DR3. But before a copy of this shell script, maybe you have some question. For example, what is this? In the above, I defined the data set to DR3, okay? But at the end, I want to save all of my result as a preamble inside the result.tex, okay? And I want to print DR3 in a capital form. If I echo my data set, all of the words are in the short form. I want to change it and print it in the capital form. In this scenario, you should just come here and put your data set in a curly bracketed, and after the data set, just put this. You see, now the DR3 is printed in the capital form, and I can save the data set in my result text as a capital form. Maybe another question you face it, what is this? Why I am using 2 backslash in here? Please let me see what will be happen. If I write printf and just write the new command for our macros, you see the printf inside it will be ignored from the first backslash. Now I want to put another backslash because it will be ignored the first one and now will be considered the second one. If I run it, you see now in this scenario, it removed the first one, and in the second one, consider the backslash n as a new line. For avoiding this problem, this is better. You put 2 of these backslashes inside it, and you see, please let me reset my command line. Okay, excuse me. And you see now it's printed as a correct. Now I want to copy all of these, come inside my directory of source and then write the analysis dot sh, paste all of this here and save it, close it. Now I should change it and it should be executable. Now if I run my analysis.sh, you see all the stars are downloaded from the Gaia. And if I see the report, let me see this file. If we see this file, the content of this file, excuse me, result of tech, you see all of these macros are saved inside my result.tech. But maybe you don't like to use this AST query because this is one of the program inside the GNU Astro. If you want to, if you are in the IAC and you want to use the IAC computer, just if you write the model load GNU Astro, the GNU Astro will be activated. But if you don't want to use this, this is very easy. Instead of this, you can come here and use this curly. Let me copy this, come in and at first remove my results and then go inside my analysis and remove this one and paste the curl. Oh, excuse me, I forgot to copy it. Okay. And now I want to, what is happening? Okay, now it's, if I save it and close it and again run my analysis again, you see all the stars are downloaded. And if I look at to my result, again, all the macros exactly like in the AST query, which are used from GNU Astro, are saved inside it. Now I make this file inside the, I make all of these macros inside this file. Now I can include all of this file inside my LaTeX source. This is very, very easy. You should come to the in preamble region and include the results analysis as LaTeX macros by input, excuse me, input. You should just write name of this file inside your input in results.tech and then come to your main body of your text, for example, after this equation, and report your result in here. I want to write within a radius of which radius? I don't know. I should come here and copy this one exactly like the previous work. Write it here within this degree around coordinate. Which coordinate? Please let me at first define it, and I want to use this one and change instead of this right and write deck. If I come here, you see the write and deck defined by this variable, and then report my result. We found $, how many stars? 103. From where? From Gaia. But which data release? The data release is here. Oh, excuse me. Again, I come back here and paste it in this part. If I save it and run my, let me write it, my PDF LaTeX source, it is exactly after in this part. You see within the radius, please let me make it larger. Within a radius of 0.1 degree around the coordinate, this coordinate, we found the 103 in Gaia 3. Please let me show you the powerful of the macros for reporting your result. I want to open my analysis and change it from a DR3 to the DR2 and see what will be happen if I save it and again remove my results and now run my analysis and cat my results. You see now in a DR2 I found 92 stars, while in previously we found 103 stars. Okay, but please let me, I don't want to go through the main source of a tech. I just want to run my LaTeX again. Oh, excuse me, PDF LaTeX, and see what will be happen. You see, I just change my analysis, but the source understand I am using the DR2 and the number of stars are increased. And this is very, very useful for reporting your result by using these macros. Please let me start in here, and Mohammad will be continue by introducing how you can use the bibliography and insert your references inside your paper.
Okay, thank you very much, Sepideh. So I'll just share my screen and we'll continue. Okay, so this is the same PDF that Sepideh was writing just before this. So you see it's now in this example, I just put this coordinates up here. You see it's exactly, well, I'm continuing where Sepideh left off. Okay, so now, so you saw how easy it is to include your analysis into the paper. Now, one other really important feature of academic writing is bibliography. You want to be able to easily cite the works of other researchers that are related to your work and refer your your readers to the relevant papers. If you before, when you were using, if you were using the old style, what you see is what you get editors, you had to manually write these by hand, and it was really frustrating. And if you changed one order, everything would change. But fortunately, there's an automatic, there's a really nice automatic solution for this in LaTeX. So let's for example, let's go have a look. So just like before, just on a side note, I'll say we have this the lecture notes. So everything you saw this Sepideh showing this, everything we're talking about today is fully documented in this in the lecture notes for today's meeting. And you see the scripts that Sepideh used. We've tried to be really complete in describing. So if you feel the video is too fast, you can just follow the text and hopefully it will be complete. So to demonstrate citation, let's just cite, for example, this paper. This is one paper that I wrote last year. It was published last year, and it's on a similar subject. So it's effectively how to make your research archivable and reproducible. So because it's exactly related to this type of work, because in the long term, as you'll see in the next few sessions, this way of linking your analysis to your PDF, to your paper, allows you really your science to be fully reproducible in the long term and allow you to really experiment really easily a lot with this. And as you see, even this topic was actually published in a respectable journal. You see, this is the same journal that published the NumPy paper and the SciPy paper, and so it's a it's a very well-known journal for scientific software. So we want to cite this paper. So how do we do that? The good thing is, so each journal usually has different styles of citation. Sorry. So what we want to do is to, but fortunately in astronomy, we have this, you must have already heard about it. We have ADS. ADS stands for the Astronomical Data, I forgot the exact, data system. So ADS is a wonderful system for citation, for keeping track of bibliography in astronomy. And we're really privileged to have this. Other fields don't have a free service like this. Like in medicine, they have PubMed, but it's you have to pay for it to get many of these features. And but in astronomy, it's a wonderful feature that we have. So for example, if I want to search that paper I showed before, I just search the name of the author. And you can see over here, it's actually given examples. You can just come here and click like first author and then put the name of the first author. And then you search. So you just press enter. So you see in this case, you see all these papers that I've written, well, in the long term, but you don't want all these other papers. You just want like the one that I wrote, for example, last year. So if you want that, you come here and you say, okay, I know the year was 2021. So when you search that, you see, you only get these two papers that, well, this single paper that came out. But the good thing with ADS is that it also allows, it also indexes software and data of a research project. So for example, in this case, this is the software paper, and this is, well, not paper, this is actually from the ASCL, the Astrophysics Source Code Library. And you see, this is like an index, a way to index software in astronomy. And there's also data. So in the case of many papers, you'll see that there's also a data entry here that will take you to Vizier, and you can see the data that accompanies the paper, like the tables and everything. Okay, so you come into the paper like you see here, and well, you see information like how many citations it's got, how many citations it's had, you know, similar papers, metrics, so on. The important one here is the export citation. So you come here, so there's many different formats to export citation, but the one with LaTeX that works really nicely with LaTeX, as the name shows you, is BibTeX. So BibTeX is one package in LaTeX that that manages bibliography. So as you see, every item here, it actually shows the metadata of the paper. So like the authors, the title, the journal, the year, the month, so on. It has all of these things. So you just copy this, or you can just press this copy to keyboard button. You press this, and well, let's go in our source. So I'm using Emacs, so I just press Control-X, Control-F, and I write, you see down here, I'm writing here, I want to make a new file called references.tech. And I copy this source here. So if I make this larger, so you see better. So you see, this is actually all the information about that is necessary, like to cite this paper properly. So there's many components. So you see, it has all the data, but this first one is really interesting. This is called the key. You see, and by default, because ADS, you know, archives every published paper in astronomy, it uses this, you know, this bibcode format, which is, you know, not easy to remember when you have like 100 papers and you want to focus on your science. So a good way is to change this. So when you copy this, come here, and change this to the name of the author and the year. This is what I usually do. You can define your own method. Like if you want to, if you don't even want to remember the name of the author, you can write what it was about. For example, this paper is about a software called Manage, so you can just write Manage. Or like if the paper is about planetary nebula, like, you can just write planetary nebula. This is not good, of course, because you have many papers about planetary nebula. But anyway, it's up to you. What I want to say is that you can write any name you like here. So we're just going to use the author and the year format. Now, if one author has more than one paper every year, you can put a B, C, for example. So we'll change this. One other nice thing that we can later change is the name of the journal. You see, this is the long format of the journal. Well, in our citations in astronomy, usually we don't use the really long format. We just say ANA or MNRAS or APJ. So for this, we can actually define a macro here. We can come over here and say, just like what Sepideh was showing, we can say, okay, the short version of this format is CISE. So I go back to my LaTeX source up here, and I define a new, after this results, for example, I say journal name macros for bibliography. Well, I can just come here at the start and say bibliography and journal name macros. And I can just put new command, just like what Sepideh done before for the, you see, it's very general. It's not just about numbers or names or anything, it's about everything. You can even make these as functions. And then you say, okay, we call that journal name CISE, and we'll write it like this in the journal. For example, if you want to, when you later want to cite, for example, ANA, you'll see that a paper in ANA, like, let's see, if I go to the citations of this paper, we have like, let's see, we have like one MNRAS paper here, right? So if you go to MNRAS and ADS actually puts a macro, you see in the journal thing, it's a macro. So you can come here, and so for ANA we put A, and then we can also define MNRAS for the journal MNRAS. And you see, you can now, like, for example, copy this paper as well. So we can copy this, this whole thing, and again, go back to our references and put it down here. So you see now, if I zoom out a little, you'll see we have two entries for citations just now with just a simple, with just a copy paste, and then like the author of this paper is called Pepper, and then the year was, the paper was published again in 21, so we'll just call it Pepper 21. So now we have all the metadata of the papers we want to publish. So the next thing that we do is we have to, similar to what you saw before in the other cases, we have to load the package. So again, the bibliography, and we'll call this load the package load bibliography with all settings. And then we come here and we say new package, so use package, sorry, use package and deep later. And you can define an option here. One really common option is to have it easily called with the same format as BibTeX. So BibTeX is the old software that done this, but the BibTeX is hardly being developed anymore, and it's being updated. It's been fully rewritten as BibLaTeX. So in the first video, I talked about the difference between TeX and LaTeX. So it's still the same engine, but it's a more, let's say, user-friendly format that's being updated and used. So we use the BibLaTeX package, but one special thing we need to do is to say, okay, where our bibliography is, because remember, we defined the references.tex. So we say add bibliography, and we say, okay, where is the bibliography? We made the file called references.tex, remember? So if I come here, you can see my references.tex. This is the file I made just a second ago in the text editor, and that's it. So you define these at the start of your paper. Then you say, okay, we'll put a comment here. We'll say end of printable document, printable PDF, for example. And over here we say, okay, print the bibliography. Okay, and then for print bibliography, it's just really easy. As the comment says, we just say print bibliography, and that's it. So now if I, so Emacs is a really good editor. I really recommend using advanced editors. Don't just waste your time using simple, you know, kindergarten level editors. There's so many things you can do if you use advanced editors. So for example, look at the bottom here. I pressed Alt and X, so it shows it as MX, and I run compile. I write compile, I press enter, and you see, this is the same command like Sepideh was running before. And when I run this in the same editor, it actually, it shows the output of the command. So, so you see, it gave an error. So because I made a typo. What was the typo? At the start, when I was defining the option, look, it says package natlib undefined, because it's not natlib, natlib it is actually. So if I do recompile and press yes, you see, it actually, so add, oh, sorry, this was actually add bib source, not bibliography. Add bib source. So you see, this is how you see errors in LaTeX. You see, it says undefined control sequence, and it says add bib source is not recognized. So like, you know, as someone who knows bib LaTeX, when I see this, I see, okay, yeah, this is exactly because this command is not standard, and I can find the problem and fix it. So we recompile the source and add okay, bib read, okay, sorry, resource, and press enter, and here you go. This is the PDF after adding bibliography. But you'll notice, well, there's no citations because I didn't actually enter anything, right? I didn't actually cite anything in the paper. So for example, let's come here after the first paragraph of the introduction and say, like this paper, we can say the analysis of this paper is fully reproducible, right? And then we can say, okay, C, how is it reproducible? We can say C. So the command is cite T, and then you put the key that you made before. Remember in the references, we said you put this key here. So this is called the key of the bibliography. You copy this, you paste it here, and that's it. Then you run bib LaTeX. Okay, here it is. You see, it says the analysis of this paper is fully reproducible. See, Akhlaghi 21. But it's not the citation format I was looking for. And in the end, you see, there's no bibliography yet. The reason is that bibliography is itself a really complex thing, and we don't want LaTeX. The designers of LaTeX were really smart. They didn't want to bloat it up with many, many things, because bibliography is just one thing, right? You have many, many components, and if you want to add all of those, it will become Microsoft Word, which is like hundreds of megabytes, and it's a huge software, and it's a crazy thing that no one can manage except people that are paid to do it. But if you want to, you know, a professional software is written in a modular way that you as the user can load the packages you want. So for bibliography, to create the bibliography, let's just make let's just open a terminal. So I show you first on the terminal. To create the bibliography, there's a command called, in the case of bib LaTeX, it's called biber. So after running LaTeX once, similar to the auxiliary files you saw before, another auxiliary file is created for bibliography. So you run biber on the source. You don't include any you just write the name of the file without any suffix, and you press enter. So then this biber is actually runs on the auxiliary files that LaTeX has created, and look, it actually does the analysis. And it says, you see, like found one cite key in BibTeX in this section, you see? So now this biber generated the bibliography we want. Now if we run PDF LaTeX one more time, here you go, you have the citation, you see? This is exactly the citation in the format that, well, is general. So it's not just limited to astronomy, this is very general. And that's why, like over here, we don't have the year. And if we come down at the bottom of the paper, you see we have the full information of the paper, the author, the number, and it shows that other people were also there, the title, the journal name, even the month, the DOI, the archive link. everything that's necessary. So any reader can just easily click on this and go to archive and read the paper, for example. So this is the default format. Well, the default format is as you see, very basic, right? So and another thing is that you see the links are now different colors. Remember, Sepideh changed the colors of the links of the inside the text, the label and the refs, to blue, but the citations are green, and then the URLs are pink, right? This is the default style, but you know, it's not common in journals. Like when you're reading a professional paper, all the links have one color because you don't want to you know, distract your readers with all this extra color information. So we can just come back to our LaTeX source, and when we were loading the hyperref, Sepideh already showed you the link color before, but there's also the URL color and the site color. So in the part where we load the hyperref package, we can just come here and say, replace this and say, give many more options. We can say, I want my URL color to be blue, I want my site color to be blue, I want my link color to be blue, and so on. So when I run this again, you see now my PDF is all the links are a single color. So it's and you see the author name. So this is also here. Now BibTeX also has some options that allow you to customize how it works. So for example, you see over here we've added a full set of options to make it look more like you know, the astronomical journals, and we can just copy this whole thing. Come here, you see over here we can say, for example, no URLs. We don't want any dashes. We don't want any archive links. Like we want the maximum number of authors to be 2. We want to link. We want to have the Biber backend with the maximum number of citations, the authors, and then the style should be author year, because this is what we use in astronomy a lot. And then over here, this is the same as before, that we load the references.tex, and this is just some basic things to remove some non-standard things in astronomy that our journals usually use. But the good thing is that in general, you don't have to worry about these things, because when you load the journal style includes this bibliography styles. So you don't have to worry. We're just putting it here so you see how the journals do it, you know, just to understand the logic behind the steps. So now I added all of these. If I go back to the source and, like, for example, zoom into this citation here, and then rerun the LaTeX source, look, now you see the thing changed. It changed to Akhlaghi at all, but then it put the year here. Why did it do that? Because my Biber, the Biber one before, was with the old style. So because I changed the style, I should rerun Biber. So then I just run. I'm writing down here again. If you look, mx compile, and then I say Biber and report.tex. So I run this. Okay, my bibliography is updated, and then when I compile my PDF LaTeX, okay, now it looks like a proper journal citation. Look, you see that we have in astronomy. You see the name of the author, and you see you have a link, which is the year, and then you come down to the last page, and we have the journal, the name of the authors, and this is much more similar to the style we use in astronomical journals. And this is how you do it. So then, for example, as I showed you, like before, we put 2 references, right? So for example, say I want to cite this paper as well. And then, so since this paper also used the fully reproducible analysis, then we can say Akhlaghi et al, and then we can say like similar to, like cite T and the key that I set for this paper. And then, then I press compile, but have a look. Nothing got added, and again this is in bold. So this again shows you that you need to run Biber because you changed the bibliography. So you have to come here and you run Biber one more time, and then you run PDF LaTeX, and here you go. Now you see you have both citations here. And the good thing with this citation style is really powerful and really nice. For example, if I want to put them together, I can just come here and say, this analysis is fully reproducible, and then I just put cite P, for example, and I want to say like put both equation, put both citations in a parentheses. So look, it says, you see, both of them are now in parentheses. And then I can add like a note even after it inside the parentheses. If I come here, I'll just press a few spaces. And then if I come here and say the papers, for example, I add any text like example, right? For example. And if I run it, you see the for example gets printed after the citations within the parentheses. And then you can add even things before, like you can come here, where did I go? And you can say put C before it. And if you run it again, you see like the C comes at the start, and then the for example comes at the end, and you can cite as many papers as you like, and that's it. And then so when you want to submit to a journal, you just copy the journal style, and you have to, everything becomes so easy. And well, here you go. Here, this is the general outline of how to start doing citations in in your final PDF, and have a nice link. You see the two papers are here, one of them in NRES, the other one in CISE, and you can just click on them and it will take you to the journal page. Like this paper is a simulation paper, yeah, you see like the authors are here, and your readers will really respect you as the author to give them this much easy reading. They don't have to go searching the name of the journals to have the links. Okay, so one promise that we gave at the start of this session was that the previous session was that with LaTeX you don't have to worry about the technicalities. You can just focus on your text, right? And as you see, we've done all of these preparations, so you can now easily add new citations. Write your like my exciting research does this and like that, or like I'm using this wonderful new data set and so on. But all of these lines at the start of your document are really annoying, right? There's too much technical things that really distract. When you want to write, you don't want to see all this dirty coding and parameters and things like that. And this is one complaint that some people usually give, that like I don't want all of these technicalities. Well, there's a really easy solution, and that's exactly what Sepideh already showed before. Remember this? Input.tech. You just come at the start of your document, from the very start of the preamble all the way to the end. You copy everything. You just cut it out. You see? Nothing else. And then you just say load preamble, right? And you say input. We make a new file, preamble.tech. That's it. And then you make a new file. I'm writing the new file name down here, preamble.tech. Here you go. Now look, all of my preamble is here. So when I'm writing my paper, I don't have to see all of this dirty settings and parameters and things like that. They're all up here. And and when I'm writing my paper, you see, you just have this single line up here and everything. And because, well, over here this includes the name of my project and the name of my co-authors. So, and I like to see, I like to have this in the top page as well. I just bring this like title and authors I define here. I just define title and authors. Okay, there you go. You see, you just have these two lines. You load the preamble, and then you start your document. You start your science. You don't have to worry about any of this dirty settings and parameters and all of these extra curly braces and brackets and things like that. None of them. You just focus on your paper and you write all the exciting things you've been doing. So now that I've done this, if I recompile the project, you see, nothing changed. The PDF is the same, because LaTeX simply just includes all the contents of this the moment it hits the input line. So for the final PDF, there's no difference at all. You have everything here, and but everything is nice and clean in the top level file that you're creating. Okay, so I think we're on the 1 hour spot, so maybe I can stop here and put because I was planning to go into also cleaning your directory, because have a look over here. We have all of these extra files, right? If I go to a terminal and if I do an ls here, look, you see all of these extra files were created, while effectively the ones that I created are only this analysis tech, and I just had the report.tech. And even this results.tech is extra, because it's the output of my analysis, but I put that in the PDF. So this is an automatically created file. So all of these files are extra. So in the next session, we'll talk about how to keep your top directory clean. So you only have the files that you have written by hand and are valuable, not the files that are automatically created. So I'll stop here, and please join us in the next session, and we'll go over how to keep everything nice and clean so you can focus on your research and not have to worry about all of these extra technicalities. Okay, I'll stop here. Thank you. Carlos, you're mute.
Oh, sorry. Thanks, Mohammad. Thanks, Sepideh. Very nice. We're getting warming up here and getting experts, becoming experts in LaTeX.
Yeah.
Let's go with some questions or comments that people may have. As usual, people can raise their hands or put a question in the chat, or simply say that they have a question.
Okay, I guess everything.
I mean, we are using with the citation system here. We use with the bibliography. We're using like the default, right? But it's like they do for the journals. It's easy to then adapt the format that the bibliography will come out in any specific format that you want. Usually journals provide that. Right?
Exactly. And that's the beauty of it. Again, you don't have to worry about anything. You just write your science. And it's wonderful. Yeah. It's so powerful.
You mentioned that, for example, in this case, the input data is coming through the shell script, but one could, of course, just get that output from any program.
Yes.
Right? Python,
yes.
See anything.
Yes, exactly. So the important thing, maybe I can just share screen. The important thing is that you want, if you're using Python, if you're using Shell, if you're using, I don't know, R, if you're using Perl, I don't know, any language, any high-level language, the important thing is that you want your output to be in this format. Cat results, maybe with Emacs we have better color coding, results.txt. So look, you want the output to be in this format. So if your script is in Python that generates these numbers, fine. Just set the Python to print these lines in a file. If you're using R, if you're using Julia, if you're using Java, whatever language you're using, just create an output in this format. You give a name to your, the macro to represent a number, and you put the value in curly braces after it. Yes. So maybe one tiny point about the names is that the names should not include numbers or hyphens or underscores, nothing, only characters. This is one maybe annoying part, but yeah, this is the definition in LaTeX, so it's beyond our control. But you see all the macro names should only be characters. You can be capital, you can use capital.
It can only be numbers, right? It cannot be numbers or
no, you can't put like project 23 or like RA star 21. You can't do that. It has to be only characters, or no space, only alphabetic characters.
And they have to begin with the backslash.
Yes, the name of the macros, because the macros are, because in this case we're not using, we're using a very simple macro, but you can also define a full argument. You can take arguments, and so it's a full command. So yes, it needs to have a backslash at the start, and also in your text, when you say report.ter, in your text you should also, as you saw in the case of Sepideh, you should include those backslashes. You see, we have the backslash here.
All right, I don't see any other questions coming or comments. So I think maybe we should leave it here, and well, we usually wait for the next session.
Yes.
Hopefully within weeks or maybe a month.
Exactly.
Thanks a lot.
Thank you for coming, everyone.